Okay, thanks. Let's start. So we're on time. Thanks everyone for joining this virtual session for the user group conference. And my topic is about zero-shot learning in modern natural language processing NLP. My name is Andrej Baranovskij. Just very quickly, a few words about myself. So I have around 16 years experience working with Oracle development tools, and for the past 3-4 years, also working on another stream on open source with different Python, JavaScript, machine learning open source libraries, and kind of bringing my Oracle knowledge and open source knowledge all together to solve different problems. And I'm Oracle Groundbreaker ambassador and TensorFlow certified developer as well. And I'll have just very few slides, and most of the time I'll be going through the source code and through the notebook and explaining just with practical steps what is this actually zero-shot learning and how potentially you could apply it in your project. All right, so in general, before I would jump to the source code and to the technical things, just quick explanation what is this zero-shot learning actually is. So traditionally, when you do machine learning, you would have input data and some labels, so that you would have mapping between your input data and labels, and algorithm would be able to build the model, would be able to learn and in advance, so that when new data would come, it would do some classification, for example. But traditionally, you would need to have training data, so you need to have examples and answers. And this is fine for many cases, but also when you would like to work with text, you may get a problem because you would need to collect a lot of examples, a lot of different, for example, sentences and so on. So if you're building some sort of classifier to detect sentiment in a text, this means you need to aggregate a lot of positive sentences, a lot of negative sentences, and so on. And also it could be different domains, depends on what type of let's say topics you're working on. You may work on financial data or general data or some other stuff, and you would need to get to construct this data. So this is the problem, how you would build the data for training. And with zero-shot learning, it brings the answer where you could use pre-built model, which is built by someone. In our case, we'll use model which is built by Hugging Face open source library, and this model is actually trained based on a very large set of text from the internet, from the Wikipedia, from the text that is available online. And then what you do, you actually take this model and you're using the rules that are already built inside that model. And you could either use it out of the box and pass certain sentences and do classification, do the text generation, for example. Or if you want, you can even fine tune this model with your own custom data set, because maybe you are solving a task that is related to some financial domain, and you have some specific keywords which are not available in the main model. So you could build your own data set, pass it to the fine-tuning algorithm, and build your own model on top of this base model, let's say. And okay, with the example which I'll be showing is actually based on use case which allows for the given sentence to understand where the sentence belongs, to which topic. And as a user or as a developer, you could provide your own labels, and you could test like to which label this sentence belong with higher probability or with lower probability. And so you don't provide training data, you just provide labels, and without training data, you get the answers. Like most likely the sentence belongs to label A, label B, or label C, for example. Yeah. So, and if you want to read more in detail about what is zero-shot learning, because it would not be we would not if you go into too much technical detail, it would not be enough 45 minutes. So we would need a couple of days to discuss it. So there's a link available here, and I can just if you want to open it right now, I can copy paste it to the webinar chart, and there it's actually explained how Hugging Face zero-shot model is built. And why I'm using Hugging Face, because to the current day, this is the most popular NLP library, which is based on transformers architecture, which was introduced like in 2018. And currently, this is the most popular and the most advanced library, which gives the best results when you work with the NLP. Okay, and the next for the demo, so which is the main part of the session. So the demo is based on my blog post that on the article that I published online, and also if after the session you would be interested to get slightly more details, then you could go through the blog post where I describe the source code. So that would be another link. And finally, I'll be going through the source code which runs on Google Colab. And if you want to follow me along and run it together with me, then you could navigate to this notebook, which is hosted on Google Colab. And the source code is also available in GitHub, but again, you can download it from the Colab directly. And by the way, I was when preparing for the session, I was also checking Oracle Data Science solution, which you can access through Oracle Cloud Infrastructure. And with Oracle Data Science, you could also create a project, and in the project you can create a notebook session, and you get Jupyter Notebook there, and you could also run the same code that I'm running in Google Colab. You can run it from Oracle Cloud Infrastructure. But to share the code with the public, I think in Google Colab it's still it's kind of more, it's easier because you could just post it there and it for free, and you can share it with anyone. But technically, if you in your project you are using Oracle Cloud Infrastructure, then the same environment is available there as well through Oracle Data Science. Okay, so let me jump to the source code, and I'll also open this Google Colab, the same notebook as I was sharing with you. Okay, and so the first thing is since we actually want to use Hugging Face transformers, we need to install those transformers into current session, because transformers are not available by default in Google Colab, the same as they are not available in Oracle Data Science session. So we need to install them, and it's quite easy. We just use Python pip command and say install transformers, and we can tell which version we would like to install. Also, in this example, we will scrap results from Google. We'll see how it will work, but my idea is that I'll try to scrap them live during a demo. So hopefully that would work. And I'm filtering results from Google and using for this demo English results, and for that reason I'm using this LangDetect library here. Okay, so in this case, let me connect to the session. And by the way, this session is using GPU runtime. Otherwise, with CPU it would work as well. But when we do classification with zero-shot model from Hugging Face, it's a bit slow. It take a couple of seconds, and for the single classification. And since we'll do multiple classifications, like 100 or more, so with GPU is faster. Okay, so we're connected to runtime, and now we do installation here. And by the way, so for those who are not familiar with concept of notebooks, notebook is an environment which allows to run Python code in sections. So when you have normally Python script, you can run it, but it would execute all the code inside. But when you do machine learning stuff, it's more convenient to have separate sections and split script into sections, so that if you have some bug or you're researching how to implement certain part of the script, you don't run entire script because it may take time. Instead, you can run a single section as many times as you want without executing everything. And typically, when you're done implementing the use case, you have the option to export all the Python code from the notebook to the simple Python script. And then you're free to use that Python script in production and just run it from command line or from the shell process as you wish. Okay, so here right now installation is done fine. So we were able to install Hugging Face library and Lang Detect library. And the next step, we would do a couple of imports so that we would be able to do web scraping and also classification. So we do the import here in this step. And then the next step is where all the fun starts, because we are starting to use transformers here. So we are actually referring to the pipeline. And if I check the imports, we see that pipeline comes from the transformers library, and pipeline is sort of a wrapper that helps to make things simple. And instead of using directly Hugging Face API, we could use the pipeline, and we could specify that we would like to do zero-shot classification right now. Right. And then as additional option, we can specify that we will run this pipeline on GPU. So we say device equals 0. By default, it would run on CPU. Okay, and then as we refer to zero-shot classification model in this pipeline, when it's being initialized, it needs to download for the first time from the Hugging Face repository. It needs to download the model, which could do zero-shot classification. And this model, when I was showing the slides, and I explained that the model is already pre-trained, in this case by Hugging Face, or actually Hugging Face hosts the library of different models, and anyone can train the model and upload the models there. For example, if I go to Hugging Face models, you see that there are lots of different models and different languages are supported. So it's not only English. There are models that supporting multiple languages. There are different models that are targeted for specific language, like German, for example, and so on. And anyone can train and upload the model there. So, okay, in this case, we were able to get the model. It was around 1.6 gigabytes, and model was downloaded to the session, initialized, and we got reference to the pipeline through this classifier variable. Okay, in the next step, there's some part of custom code, which actually executes call to the Google search engine, and it's scrapping some data based on a query that you provide. And I thought to make it more interactive, and instead of having some data that is predefined in a CSV file or in database, just to do live scrapping, and let's see how it works. I would not go through the detail through this, how the scrapping works in this case, in this function, but in general, what it does, it's the idea here that first we're executing Google search result programmatically, like we are pretending that we're actually executing it from the browser, but execution is programmatic from Python environment. And then we get pages from Google search, and then we go into each page inside, and from the page we are scraping text data. And then for every paragraph we are treating it as a separate entry, and we are storing in a local storage here in the session. And then at the end we are producing CSV file, and afterwards we are using the CSV file to calculate the sentiment. So as you see with NLP, like with any other machine learning exercise, a large portion of work, it goes to the data preparation. So the model training is probably around 20%, and everything else is 80% is to fetch data, transform data, clean data, and afterwards, when model is trained, then you would want to evaluate the model quality. So you would need to have test data. And once all this done, you would need to deploy it to production. And once it's deployed, you don't want to keep it there running forever. You would like to evaluate if model quality is decreasing, for example, then you would want to do retraining and so on. So there are a lot of things like that with machine learning. Okay, so in this case, here we are scrapping the data, so very long function. And we are storing the scrap results into Google results CSV file. And yeah, there are all those helper functions that actually doing job of extracting data. So I would execute this cell once and make sure there are no errors. Okay, it's executed fine. And then in the next cell, what we do here, actually we're executing the scrapping, and the query that I'm using, I thought the one which would bring quite a lot of results, Oracle TikTok deal news, because this is quite a hot topic, and there are a lot of discussion online on this on this thing here. So I thought it's kind of funny if I would scrap this query from the internet and just do just evaluate with zero-shot learning what is actually the sentiment, what people are talking about Oracle TikTok deal. Okay, so let's start scrapping. It will take a couple of seconds, I think, and as it goes now, we see that it prints the log, and it actually starts here with the first results from Google, and then goes. I think it we go next to 500 or 100 pages we go through, and we actually get the text from there. Okay, so let's give it a minute or so to run, and then as a result, it should produce the CSV file, which would store all the scrap data here in Google Results CSV. And then once it's done, then we actually we have the option to load the file to the memory, and there's a very handy library available in Python called Pandas library, and with Pandas we can read any CSV file in a very convenient way, and it's parsing all the columns out of the box, and we are getting some sort of data frame where all the columns and cells from the CSV file will be populated, and we could operate with this data structure directly for the Python code. And this is quite convenient structure when we would like to feed this data to the machine learning algorithm for training. And while it's actually scrapping, we can see that previously when I was running this scrapping exercise, then probably a couple of days ago, so by then it was actually fetching some sentences like this that are related to Oracle and TikTok. Quite a lot of text. For example, this one saying some administration issued 2 executive orders concerning TikTok and so on, and related to the Chinese government and so on. There are when we are doing scrapping, there is some garbage as well would be in the results, and this is the question of the quality of the scrapping. Like you could invest more time and try to catch content which is not actually the query related. Like here, there are some text, technical text was extracted from the web page, which is obviously is garbage. So while you could actually invest more time improving scrapping, one thing, or there is another option with when we run zero-shot classification. One of the topics you'll see later, we could specify as some topic which is unrelated to other topics, and then zero-shot model is actually able to classify all those unrelated text and assign to this unrelated text separate topic. And in this way, we can filter data that is being scrapped and separate the one which is actually unrelated, like garbage. Okay, so scrapping is done. And now if I could try to open CSV file. Okay, so I can see the data is there. So there's one column with content, then there's a URL, and there are some other technical labels there. So we can see that data was scrapped successfully. Then we can load the CSV file into the data frame. So in total, there are 1,670 rows being scrapped for this query. And then if I print out some of the values, you see that there's a new text is being displayed, and yeah, and now since we have lots of text, now we want to do some logic, and we would like to analyze the text and see the meaning. And this is where we actually do right now this zero-shot learning. So the idea is that we can provide array of labels or topics, and this could be done either by developer or by the user through the. In this case, this is done in the source code, but we could have UI as well, where users would pick some labels and submit requests. But in this case, we're just doing it in the source code. So we have array, and in this array we can provide different topics, like I do now, like politics, business, cloud, security, and then this one which is completely unrelated and to the first four, and it's called advertisement. And what I noticed is that Hugging Face is able to detect text which is either it's direct advertisement, like you would get online, lots of advertisements, and you don't want to have this noise, and you don't want to affect advertisement text. You don't want to interfere the text from the advertisement with the main text. So you would like to separate those sentences and ignore them. And as well, when we get like a technical text, like some JavaScript source code, which was scrapped by the scrapper, is being, it also gets classified very often as unrelated text as advertisement. So this is useful. Okay, then we have another array where we provide a couple of values that actually match. So the number of values here should match the number of topics, and this is just a helper array which could we are using to calculate how many sentences are classified with politics, business, cloud, security, and so on. And then we are iterating through data frame, through df variable, as it was initialized in the previous cell with the data that was fetched from the CSV file. And then as we iterate here, we get a sentence for in each step. And then for that sentence, we are calling our pipeline classifier. So this classifier pipeline, like in the beginning of the notebook, it was included from the Hugging Face, initialized from the Hugging Face library with model for the zero-shot classification. So we're calling the pipeline, providing our sentence, and also we are providing an array of labels that we would like to evaluate, and the model should tell us which of the label is more closely related to the given sentence and so on. And okay, then this actually returns the a set of arrays, and this one of the arrays returns scores. So for every label, you get a score with probability. Higher the score, so higher the probability that sentence belongs to this topic or label. And then another array is labels, and scores and labels arrays both are actually ordered in the same order from top to the end. And in the first position, you get a label which gets the higher probability. Okay, then we are calculating the top one, and we are extracting information about this top top label, getting predicted class and predicted score. And then we're doing some statistics. We are just incrementing the ID, which belongs to the label which was currently classified by the pipeline. And in some cases, there are sentences that are completely unrelated, and pipeline returns very low probability for either of the topics. And we would like to skip those sentences, and we are only looking for the sentences where classifier returns probability higher than 50%. Okay, and now since we run on GPU, this should not be too slow, so we can let's execute it. It should take maybe 20 seconds to process 607 sentences. And as it works, we can see that different sentences, and in the first position we get like politics, business, security, and this means in the label which comes in the first position, this means the one that gets higher probability, and this is where our sentence most likely belongs. Okay, and once all this calculation will be done, then we actually can print out the results and display them. And one thing is to mention, by default, the zero-shot learning, it does single class classification. This means out of all the labels that you pass to classifier, it tries to pick the one that is more likely related. So it picks the result should be single class, so the one which is more likely related. There is another option if you pass multi-class true to the classifier, then it would execute multi-class classification, and it would return separate probability for each label without looking into the other labels that from the array. So it would just check without comparing with other labels. It will check what is the probability that current sentence is about politics, and what is the probability that is current sentence is about business, and so on. And all those probabilities will be unrelated between each other. So this would be a multi-class. Okay. And the main beauty here is that it's in its simplicity, because it's very hard for this task. It may look as a simple task, but in practice, it's very hard to get the data first, and then get the proper data where you get proper labeling, where you get in advance, you would have a label that would identify the given sentence as a politics, business, or cloud. But with zero-shot classification, you don't need training data. And you saw here that I was not doing any training. I'm just using the model, which is available out of the box. And I'm providing the labels and providing sentences, and I'm getting back the probabilities. If you want to run this model on top of custom text, because by default the model is trained on a text from the internet, on a public text. So if you have something specific, you actually have the option to do fine-tuning. And this, if you go to my article that I referred earlier, there is another post on the same blog where I explain how you would do fine-tuning for the Hugging Face model. Okay, so in this case, it's done, executed, and we could print out the results. So we see that there are business, and let's print it out also visually. So the top results are related to Oracle TikTok deal, are related to the business, and second place goes to the security discussions, and still quite low there are politics. And cloud, it's actually not getting too many points, but probably because business and cloud kind of sentences would be related, and probably in most of the time classifier gave higher score to the business once classifying the sentence. And probably there were some cases very cloud specific, and those were classified as cloud. Okay, for example, this one, the last result is actually classified as cloud with 79% probability, and this is what they talk about. The confirmation that Oracle will not acquire TikTok US outright, but rather provide underlying cloud infrastructure, blah, blah, and so on and so on. And yeah, it's not a very long sentence, and it talks about cloud infrastructure and doesn't talk about business probably too much. There is some mentioning of agreement and so on. And if you look into the list of probabilities, so we see 79% cloud, and there is slight chance for business, 15%. So probably because agreement was mentioned. So classifier gave 15%, and for security it's just like 1%, so it's very low. And there are some quite a lot, actually more than 50, close to 75, I think it's advertisements. So this is the garbage, that the text that is unrelated to any of these topics, and probably there are some some text from the advertisement or some technical text. For example, this one advertisement, 81% is talking about marijuana and completely basketball, and there's some garbage, and it's being classified as unrelated topic in our case. Okay, so now we did in this case we did single class classification, and we could also since it takes quite fast, we could rerun it, and with a different option, with multi-class classification true, and we could compare results, and the results would be different because in this case we would be able to catch a slightly different perspective, because since in previous example we were always getting only the first one, the most popular label with higher probability, and in those cases where it kind of splits between business and cloud, if classifier thinks that business is more, the sentiment for business is stronger, it would be classified as business and not cloud. So in this case, the picture may be slightly incomplete. But with multi-class, for each label, we get separate its own probability, and then we could check, for example, if the probability for the certain label is higher than 50%, then we could assume that it makes sense that probably this probability is calculated correctly, and then we increment our statistics for that label, and this means that the same sentence could be classified and politics and business, or business and cloud, for example, or all three. Depends how long is the sentence, and depends what is the meaning of the sentence. Okay, and while it runs, okay, this example is based on a very popular query, but in how we're actually using it with our customers, there are at this moment we have two use cases. One is support, which is quite popular use case, where we are classifying text which is coming from the consumers, from the users, and we are trying to detect if escalation is needed, for example, or not. And then automatically, if escalation is not needed, there's some default answers being sent back to the person. If escalation is needed, then this request is being assigned to the analyst who will follow up to the person. So this would help to improve the service of the company and filter out minor requests and help to focus on some important stuff. So that's one use case. Another use case where we are applying this is for topic modeling. So the company is doing some analytics, and for example, they may have a request to analyze the market situation, and what they would like to do is to execute a query and check what people are talking online about some company, or about some product, or about services, and so on. And then we fetch data from internet, from Google, from Twitter, from Instagram, for example. And once we have all this data, we actually doing processing of the data, and there are some algorithms that help to split all the different texts into groups, and to be group those text by the topics, and then we can see what actually people are talking, what are the topics, and then we can deep dive into topic, and we use the same zero-shot learning model, and we assign different labels, and we try to identify what people are talking inside the given topic, like is it something positive, negative, and so on. So this helps to build a picture of what is being discussed about brand, about company, about so on online, without expensive data preparation for training. Okay, so now we got multi-class classification is finished, and we got slightly different numbers here. And if I would print out the results, we see that now we get business and cloud. We still have business, politics, security as the three most popular, but then we get slightly more cases for cloud. And now, so here the cloud was around 50. Now we get above 200 for cloud. And this means that we could extract data in more precise way, and we could understand the actual meaning of the sentences in a more granular way. Okay, so that's probably all. And as I shared in the beginning, this notebook with you could follow me as well and run it on your environment while I actually speaking and showing. If you was just listening to me, you can do it afterwards. This notebook will stay available forever. I'll not remove it, and you could refer to the source code as you want. So that's in the last slide, you would see my contacts, and I'm posting machine learning specific articles on towards data science. There are a lot, quite many of them already. If you would have any questions or follow up, just you can ping me on Twitter. That's the simplest thing. So yeah, I'm done. And if you have any questions, I'll be happy to follow up either right now or afterwards. So it depends. See.
Thanks very much for that, Andrej. If anyone's got any questions, you can either put them in the Q&A box or in the chat box. I've got to say, I've not actually used the that notebook type function there, Andrej. I thought that was absolutely fascinating. I've never tried that, so I think that's on my list to do.
Yeah, it's very convenient because you can share it with others as well. So it's you can make it private or you can make it public. So and it stays there in a Google Drive, and then the file is being loaded automatically from the Google Drive. It's quite convenient.
I like that. That was good.
Yeah, and another advantage is that you can print out charts like in line. So when you run Python script, you don't have option to display chart so easily. But in Notebook, you just execute the code that renders chart, and you get the chart immediately. So it's quite convenient.
Yeah.
Okay, so I think there are no questions. But if anyone would have questions afterwards, feel free to ping me. I'll be happy.
We do have one question here from Grant Ronald.
Okay.
Any recommendations for how you can discover the topic of a single sentence?
Okay, so the topic of single sentence. So the only way, as I was showing here, is to try to bring a set of labels, predefined labels, and execute with those labels the classifier pipeline, and then it would return probabilities. So you still need to assume that probably a set of different topics, and what classifier will do, it will tell you, it will from this list of topics, it will pick the one which is more closely related to the given sentence. And if it's a single sentence, so obviously, like I was running a loop here, so it's quite simple. You just, instead of running a loop, you would say classifier and pass the sentence here and execute it in one line and get the result. So it's just one line of Python code.
Hopefully that answers your question. Oh yeah, we got a thank you.
Okay, and good.
Cool. Any more questions? We'll just give it 30 seconds to, or a minute. People can take a little while to be typing their questions in.
And by the way, there is also the multi-language is supported as well. So if you want to do this similar sentence classification in different language, German, Spanish, or there are 100, I think 104 languages being supported. Just instead of using default model, you would need to use slightly different model. And let me, well, we have some time. Maybe I could, because I have another model where actually I'm using multi-language. So let's see. Okay, this is the one. So here I'm processing Lithuanian language, but in general, when you do refer to the zero-shot classification, and you need to reference this specific model, and this model gets more than 100 languages supported, and you could process the topics based on different languages in this way.
Cool. I think if we've no more questions, we should wrap up.
Yeah.
Can I just say thank you very, very much for your time, Andrej. It's very much appreciated. And thank you all for attending.
Yeah. Thanks, guys. Bye.
Bye-bye.